Alright, welcome to another episode of your and Mr. Demuth's class, and I'm not. Now, we've already done problems 1, 2, and 3, but just for some reason, in case you were a student that missed this, this problem is asking us to find the distance between Sesterich and Sanchez. But here's Sesterich, here's Sanchez. Okay, so if I wanted to find that distance, what you're going to need to do is you're going to need to draw a right triangle. So we'll quickly do this so you know exactly what I'm expecting you to do. Alright, so you draw a right triangle, you check this distance right here, call that 3, and count 1, 2, 3, 4, 5, 6, 7. So this is 7. You're going to use the Pythagorean Theorem, a squared plus b squared equals c squared. These are the two legs. Alright, there's the hypotenuse. We're going to take 3 squared plus 7 squared, which equals our hypotenuse right here. This is going to be our hypotenuse right here. That's the distance we're trying to find. So we get 9 plus 49 equals c squared. Add those together, you get 58. And then the last step is you take the square root of both sides. So c is equal to whatever the square root of 58 is. Now, that can't be simplified as a radical because the only factors of a 58 are a 2 and a 29, and both those are prime numbers. Okay, so if that's a prime number and that's a prime number, alright, those are the only factors of it, so you can't break those down, so we're just going to get an approximate value. So we're going to go over here, take the square root of 58, and that'll give us the approximate value of 7.6. So we're going to go right over here, take that and say that's approximately equal to 7.6. Now what does that mean? Okay. Now this says this is tens of miles, and if you look down on your paper it also says tens of miles. That means each one of these distances, like from here to here, that means that is 10 miles. So from here to there, that would be another 10 miles. That would be a total distance of 20. So what we're going to have to do is you're going to have to take this right here, the 7.61. We're going to have to take that and multiply it by 10, and that will give us the actual distance from Sesterich to Sanchez, which is about 76.1. Okay, we could say 0.2 since that's a 5. 0.2 miles. Okay, so if you go back over here, all right, if you take this right here and you multiply it by 10, because each unit is considered to be 10 miles, you could round that to 76.2 miles, and that's the answer to that problem. Now, moving on now. All right, if it says solve for x, you're going to notice that we have a right triangle next to a right triangle right next to another right triangle. So I'm going to label this C, I'm going to label this A, I'm going to label this B. Then I'm going to label this C, all right, call this A, and call this B, call this side A, and finally call this C. So we have 3 distinct triangles. Now what I'm going to do is I'm going to trace these. For those of you who have not done this problem, I'm going to trace this one in blue. Okay. Then I'm going to trace the middle one in red, carefully. And the last one I'm going to trace in green. Because while this right here, this is side B in the blue triangle, it is side C in the red triangle, because this is the hypotenuse. Anything that's across from a 90-degree angle right here is considered to be the hypotenuse. Just like right here, this is the 90-degree angles, which means that side 17 is the hypotenuse. Now, one of the most common Pythagorean triples is the 8, 15, 17 triangle. We'll call this A, we'll call this B, we'll call this C. Alright? So I know this side B is a 15. But if you didn't know that, you would have to use the formula called B squared equals C squared minus A squared. Okay? So I'm going to put B squared equals 17 squared minus 8 squared. If you were to do this in the calculator, you get 289 minus 64, which gets you the 225. Take the square root of both sides. b equals 15, because 15 times 15 is 225. And that's a Pythagorean triple, so I'm going to put a 15. Now, the next thing we need to realize, if that's a 15, well, guess what? Now they share the same length. So that's a 15. That's a 9. We got to do the same formula. So on here, watch in red, I'm going to do the same formula. b squared equals c squared minus a squared. So this time, we do have another Pythagorean triple in play, but we'll just go ahead and work it out. So we have a 15. We're going to take away 9 squared, because there's the 9. And we get 225 minus 81. And that becomes 144. And when you take the square root of both of those sides, you get another Pythagorean triple. Now this Pythagorean triple is basically a derivation of the 3, 4, 5. The 9, 12, 15 is the same as the 3, 4, 5. It was just all multiplied by a 3. 3 times 3, 4 times 3, 5 times 3. So right now, I know this right here is a 12. Now, for the green triangle, this is what you have to do to finish this. Okay? I'm not going to give you the answer, but this is what you have to do to finish this. You got to take the 3.5 squared. You got to add the 12 squared. And that's going to give you your c value, also known as your x squared. So you need to finish this one on your own, and this time you're looking for the hypotenuse. Now moving on. Okay? Right here it says determine whether triangle ABC is a right triangle. So what I want you to do is I want you to figure out the rise over the run from A to C, and I want you to look at the rise over the run from A to B. So what we're looking for here is we're looking to see if this right here is indeed a right angle. Because this right here, if there is any angle that looks like a right angle, this kind of looks like it might be a right angle. So right angles have to have perpendicular slopes. So let's check out the slopes. The slope of AB is the easiest to interpret. It goes down 1 and over 1, so the slope is negative 1 over 1. Now the perpendicular slope to a negative 1 over 1. The perpendicular slope would be a positive 1 over 1. So we're going to see if this is a positive 1 over 1. So let's check out the slope. And this is what you should write on your paper. Okay? The slope of AC. Let's see how much it goes up. 1, 2, 3, 4. So it goes up 4. And then it goes over 1, 2, 3, 4. Oh, 5. Oh, the perpendicular slope of a 4 over 5 would be a negative 5 over 4. Bummer, they're really, really, really close, because 4 over 5 is very, very, very close to a 1 over a 1. Okay? That's basically 100%, that's, 80%. Very, very, very close. So, being that these are not negative reciprocals, the answer is no. Alright? And how would you explain your answer? You would write the slopes. If you're wondering what the slopes are, this is the slope of AB, and this is the slope of AC. These are not negative reciprocals. So the slopes of AB and AC are not negative reciprocals. And yes, that's your explanation right there. No, the slopes of AB and AC are not negative reciprocals. So that's your answer. So you can put that in the box, just like that. I see the work, and again, I understand that you understand that these are definitely not negative reciprocals, which means this right here is definitely not a right angle. So it's definitely not a right triangle. Now, moving on over here, I want you to understand what I am asking you to do right here. So I'm going to zoom out just a bit. Okay? So it says, the 3 squares shown below are joined at their vertices to form a right triangle. What is the area of the shaded square? Well, very easy. All you have to do is you need to understand that this area squared plus this area squared equals the hypotenuse squared. So, to make this even simpler, the area of the gray square plus the area, we'll just call it the blue square, this area added together, will equal the area of the green square. And we did this in our Pythagorean Theorem lab, so this problem should be very, 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 very simple. We're just trying to find the area of this. So here's what I want you to write. Write a squared plus b squared equals c squared. For a squared, that's what we're trying to find. Now for b squared, what is that area? 21 times 21. Well, that should be 441 centimeters squared. So put 441 right there. Now c squared, it's already been squared for you. It's 578. So let's just check the math real quick. 21 squared is 441. So now all you got to do is do 578, which is the area of the big square, minus 441, which is the area of the medium square, and that gives you the area of 137. So the answer to a squared is 137 centimeters squared. It says what is the what? Area of the shaded square. So you're going to put, it's definitely a positive, 137. So you could put it there, or you could put it right over here. I'm going to put a 7, a 1, and a 3, and I'm going to bubble that in. I'm going to bubble the 3 in and bubble the 7 in. And that would be your correct answer for that. Now the rest of this paper is either finding areas or finding lengths. You have to figure this out, okay? So I'm not going to do number 6. It's very similar, okay? Dealing with a diagonal, very, very similar. What I want you to do is search. Now there's only two things that you're going to be finding, okay? Here's the two formulas. You're either using a squared plus b squared equals c squared, or you're using b squared equals c squared minus a squared, or you're using a squared equals c squared minus b squared. Now, if you want to find c, c will always equal the square root of a squared plus b squared. So this is the formula you would always use for the hypotenuse. Okay, so you could use this formula right here for the hypotenuse. B will always equal the square root of whatever c squared minus a squared is. This is if you're trying to find one of the legs. If you're trying to find the other leg, just so you know, a and b are interchangeable. But sometimes people get a little rigid. That's supposed to be a c right there. It's a c. So a equals the square root of c squared minus b squared. Okay? So you're either using this formula, or this formula. Just remember, in your right triangle, in case you forgot, okay? This is a leg. This is another leg. You can call this A, you can call this B, you can call this B, you can call this A, but don't forget that the C is always your hypotenuse. Good luck. Happy solving. I will go over questions tomorrow. Your job is to work on this and get exact answers to the best of your ability. Have a good day.